Today's video is sponsored by Supermicro.
Well, welcome back to Craft Computing, everyone. As always, I'm Jeff, here again at Computex 2025 in the Supermicro booth. I'm joined here by Alec, and there are a lot of tubes and a lot going on behind me. What exactly are we looking at here?
So this is our HGX, 4U liquid cool system, powered by 8 Blackwells, and this chip is B200 in XXM form factor. So this is what the system is, and we are always, whenever we talk about this, so the most important thing for this particular system is this is successor of our previous generation system that was very similar to this 4U liquid cool system, powered by 8 hoppers, and with that system, we created history. We were the first one in the market who started doing liquid cooling for HGX platforms.
Okay.
And we have done the world's largest deployment. That was 100,000 hoppers.
100,000 GPUs.
100,000 GPUs,
Wow.
hoppers
Yeah.
in XXM form factor. So that's what we did, and this system is successor of that. Not only we did 100,000 GPU deployment, the world's largest, but it is a single cluster. That is also very unique. And one very important thing I would like to point out, that we were first to market, fast to market, with that deployment, and that too we accomplished in 122 days. The day we received PO and the day we delivered the cluster.
122 days
122.
from PO signed to deployed and running. So obviously we looked at the GB300 a little bit ago, but this one is still based on B200, but this is more of a traditional x86 GPU kind of hybrid PCI Express system.
Exactly.
What can you tell me a little bit more about what's inside of here?
So inside this system, of course, the HGX baseboard, and pretty much one very important thing, inside the system, I would like to say that again, Supermicro is the only vendor who has multiple options. So this system is based on X14, right? So X14 is Intel Xeon processor 6th generation, right? With 24 DIMMs. It can support even MR DIMMs also. And then we do have version that is based on Intel's 5th generation processor. That can support up to 32 DIMM slots, so that can go up to 8 terabytes of local memory, DDR5 memory, right? And then also we do have AMD version. So that is based on AMD EPYC processor.
Yeah, and,
so
and that's AMD Turin and Genoa, the last two gens.
So that's why, at Supermicro, we do have all these 3 versions available on this one. So that is inside pretty much all this one. And as I said earlier, this is HGX baseboard, powered by 8 Blackwells in XXM form factor. And it is in a non-blocking architecture. So the peer-to-peer communication is again 1800 gigabytes per second. And it is, it has NVLink switch. So it is, in non-blocking architecture. That's what it is.
So we're looking at either a pair of Intel 6900P up to 256 core, or a pair of AMD EPYC up to, 384 if you go with their high-end Turin.
Up to highest, that is
exactly.
the highest number.
So a lot of power in here, along with your 8 Blackwell GPUs. Obviously, there's a lot of water cooling going on inside of here, and a lot of power density. Tell me more about the water cooling. Tell me more about what exactly I'm looking at here.
So water cooling, the good part is that again, at Supermicro we saw this coming, and that's why we came up with the liquid cool version. And the beauty of this particular system is that whatever you see, the cold water and the hot water that goes, the CDU and the cold plates, and as everybody pretty much knows that these systems we call that end-to-end solution from Supermicro for liquid cooling. That includes the cold plates, the CDUs at the bottom, right? And also the cooling tower. So everything is done by Supermicro, and pretty much, this is a standard that you can see there are 2 drawers. This one is for GPU, this one is for CPU, and that's how this the heat extraction is done here.
Excellent. So we talked about the CDU down below, and as we mentioned in the last video, you guys provide the CDU for basically every vendor that's out there. What is the actual cooling capacity of that CDU?
So 250 kilowatts.
250 kilowatts.
250 kilowatts, that's what it can take, and it is fully redundant. So the pumps are redundant, so if something happens and you take out one pump, there will be no problem. It will be still up and running.
Oh, wow.
So that is very unique of Supermicro. So first of all, this is for in-rack cooling, right? But we do have in-row cooling also.
Okay.
So that option is also available at Supermicro.
Yeah, and that's through the cooling tower and separate units, essentially. So it looks like inside the rack, we're looking at, 8 compute and GPU nodes all put together, and your cooling solution. What are we doing as far as networking and getting all of these linked together?
Oh, perfect. So for networking, there are 3 different options. The first one is using InfiniBand, Spectrum-X, or Ethernet, regular Ethernet. So these 3 options are there. and each one has its own merits. So to begin with, the InfiniBand, generally that is meant for if you're trying to create a cluster and that is for a single application or just few applications, then InfiniBand is the right choice.
Right.
And if it is multiple tenants and multiple applications running on this cluster, then Ethernet. And if you want to get best of both worlds, then it is a Spectrum X. Because with the Spectrum X, you can have multiple users on this one, multiple applications, and still you get 1.6x better performance than regular Ethernet fabric.
Oh, okay.
And the one we were talking about earlier, the one that we did for X.AI, 100,000 GPU node GPU cluster. So that is also based on a Spectrum X.
Okay, gotcha. And speaking of options, there's obviously a lot of power draw in here. What kind of power draw are we looking at? Power density, and what are you looking at as far as power delivery as well?
So one very important thing, as far as power is concerned, in most of the cases, we can do what customer can, what capability they have in their data center.
Right.
So this one is 8 nodes in a rack, which is a very, very common configuration.
Yeah.
But we do have option if customer wants to pack more at a rack level, it can go even up to 12 nodes in a rack.
Okay.
So that option is there. So when we are talking about 8 nodes in a rack, so we are talking about 96 GPU in a rack.
Yeah.
So that's what we are referring here. So it is for power, as far as power is concerned, it is mainly constrained by customer what they do have.
Gotcha.
Based on that we can.
Yeah, how many they actually want to put in the rack. And,
yes.
Okay, so your density is going to vary a little bit.
Power availability based on customer
Gotcha.
specific needs. We
Gotcha.
can do that.
So as I understand this, this rack in particular, you guys are trying to build as essentially a turnkey all-in-one solution for AI data centers. So basically a customer can come to you, purchase one SKU, and deploy it into their data center. Basically configure it however they want to do. Can you explain a little bit more about that process and what a customer might expect when purchasing something like this from you?
So obviously it's a very good question again, because what happens is, in general, a customer can buy a single node also from us, right? But in this particular type of solution, you can see how much complexity is involved in this one, right?
Right.
And this system is not available as a standalone node. So you can simply buy one node from Supermicro. It has to be full rack stack cable level solution because of lots and lots of complexity. Otherwise, if we ship a node only, then it might create number of challenges for customers to make it work.
Exactly.
So that is one of the reason. The second very important thing is that for these type of deployments, it is very complex in nature. So we always encourage customers to go with full rack stack cable level solution. And very recently, we are proud to say that just yesterday, our CEO, he announced about the DCBBS. So DCBBS stands for Data Center Building Block Solutions. And that pretty much covers everything, rack stack cable level solution. And that includes, pretty much, I should say, that is the whole body, what we do at Supermicro, that includes, the compute, the storage, networking, the liquid cooling, or whatever, number of things, services, software stack, everything is included in that. So you will hear a lot about that. And with that, what customer can do, they can just simply place an order with one SKU, and that the whole, the solution will be delivered to customer as a turnkey solution. The only thing, just like you buy your iPad or something, you just install your applications and it is up and running. Same thing you can do with this huge deployments as well. That's what Supermicro is gearing at.
Excellent. As a systems administrator and someone who used to build solutions for customers,
they know the pain points.
Yeah, exactly. Your pain points. What rack do you go with? What nodes do you go with? What is about your networking, your storage, everything else? With you guys, it's more buy one SKU, deploy it, and start running it.
Yes, that's what we do.
That's awesome. And you guys are also providing more than just the hardware as well. You guys are also providing a full turnkey solution for running AI applications. Like you said, basically providing the building blocks for customers to run their own data sets.
Yeah. That's what this DCBBS is for.
Yeah.
And when we are these type of customers, when you're talking about, so now the new norm is that it is not simply node, but people are talking in terms of SUs. SU is a scalable unit. That is, pretty much 32 nodes cluster.
Obviously, we already covered the GB300 in the last video that I talked to you on. This is based on the B200 SKU still. And as I understand it, that's because NVIDIA is only validated for air cooling. When can we anticipate B300 showing up in this SXM configuration with a water cooling solution like this?
So that's a very good question once again, because what happened that the B300 NVL8, now it is called B300 NVL8.
Right.
So for that the PS sample date, according to NVIDIA, what we have right now, that is July.
Okay.
So in July, the air-cooled version, the PS samples will be available, and for this type of liquid-cooled solution, it will be August.
August, okay. Yeah. So August, we can expect some more news to follow on B300 upgrades. Excellent. So when B300 launches, what kind of differences and improvements will we be looking at over the B200 based systems?
So again, for all this stuff, what we are talking about now it is everything is about GPU memory and memory bandwidth. So these two things are very important.
Right.
So for HGX, the key difference is that it is the memory that plays a very important role, vital role. And on this one per GPU, now for B300, they call it one dual die GPU per XXM. So over there, we are talking about 288 GB of GPU memory, that is HBM3E. And if you do the math, so it is going to be 2.3 terabytes of HBM3E memory at a node level.
Per 8 nodes, or no, per node.
Per node.
Okay, that's right, yeah.
So that is very, very important, very crucial, especially for these reasoning models. And reasoning models are very important because reasoning models are setting the stage for the next big thing that is going to be happen, that is agentic approach. So for agents, reasoning models is the foundation, and for reasoning model, this type of infrastructure, what we are talking about, B300, GB300, NVL72, that is going to play a very, very vital role.
Well, Alec, thank you again so much for your time.
Thanks again for having me.
Thanks
you.
again.
Thanks
Pleasure.
for your time.
Yeah.
Thanks.
Awesome. Once again, I'm Jeff with Craft Computing. Stay tuned to the channel for more coverage from Computex 2025. Cheers, everyone.